Okay, good afternoon, everyone. Nana. Yeah. Uh, if we come to the class straight away. Yesterday, I think I explained this one model related to coefficient of restitution. Okay. Like oblique collision onto the floor or wall, oblique reflection, like coefficient of restitution is equal to tan alpha by tan beta. And I gave few examples related to it. Am I right? Is it correct or wrong? Yes. Okay, good afternoon, Nana. So related to it, actually today we come to the same coefficient of restitution here. The model, like suppose from certain height, this is the ground. Good afternoon. And from certain height, if we release one ball like this, it strikes the ground somewhere here. This is the ball, strikes the ground, and then bounces back along the same line. Suppose bounces along the same line. Okay. Here, what he is saying, strikes, suppose with a velocity u, and rebounds with a velocity v. Then in the first rebounds, what is the velocity of the ball? And in the first rebounds, it raises to what height? Two questions now. Okay. Suppose if I write the description here, I think you can understand. I'm writing here that a ball is dropped from a height h. Okay. It strikes the floor with a velocity u here. Okay. And rebounds along the same line, same vertical line, same line, with a velocity v, come up to a height h1. Better I take v1. 1 stands for first bounce or second bounce or third bounce or nth bounce, like that. So better I take some number here. This is v1 at the first bounce. You had h1 in the first bounce. Okay. Then v1 and h1 are respectively. This is the question, dash. Okay. Such type of question you can see, Nana, again in one-dimensional collision. Okay. Take the coefficient of restitution as E. Okay. E is the coefficient of restitution. That's it. Okay. I think this is not a hard question, Nana. It is very simple and very basic question here. Okay. So if you see what I say, it strikes with a velocity u and rebounds with a velocity v1 means u is the velocity of ball, rebounds with a velocity v1 means v1 is the velocity of the ball after striking the ground. So u and v are nothing but the velocities of first body before striking, after striking. So before striking, he gave it as u. After striking, I take it as, of course, given as v1, I take it as minus v1. Understood? Or to be explained why I took the negative sign here. Is it required? No. Very good. So I think you understood. No need to explain. Okay, sir. So u1 equals to u, v1 is equals to minus v1. Then here, what I say, why I took the negative sign here, just to u and v1 are in opposite direction. Okay, v1 is minus v1. Then second body, if you see, it is the floor. Yesterday also we discussed before and after striking, the floor is always at rest. So before striking, its velocity is 0. After striking also, its velocity is 0. Okay. Then I am going to here, what is the coefficient of restitution? Yes, coming to here, the solution. This is the given information. And you know the formula E is equals to V2 minus V1 by U1 minus U2. According to that formula, I write E is equals to V2 0 minus V1 by U1 is U minus U2 is 0. That implies E is equals to V1 by U I got. That implies by taking the cross multiplication, you will get V1 is equals to EU. Okay. That is wrong, Nana. V1 is equals to EU. Okay. So this is what the formula we get for the velocity after bouncing back in the first bounce, immediately after bouncing. Okay. Do you have any doubt related to this formula, Nana? In the first bounce, its velocity is EU. Yeah, good, right, thank you. And then here, it bounces to what height in the first bounce, he asked here. So height means before striking, actually it is falling from what height. After striking, it rises to what height you require. He gave in the question clearly, it is dropped from a height h. So this height is given as h. Okay. Since this height is h, what I say here, it is dropped from a height h such that it strikes the ground with a velocity u is equals to root of 2gh. This is the formula in motion in a straight line. I think all of you remembered. And after bouncing, suppose it bounces back to a height, say what is this, Lakshmi Gayatri? Height root of 2gh na. Where you got that s2 minus 1? Okay. Right. Suppose it rises to a height h1, then it rises with a velocity v1 means after rising up with a velocity v1, the maximum height attained is equals to our formula u square by 2g. Okay, u with what velocity it is raising up? With a velocity v1. So u square by 2g means I have to write here v1 square by 2g. Why? Because it raised up with a velocity v1. Okay, so use v1 square by 2g. That implies I will get v1 is equals to, by taking cross multiplication, 2g h1, that is v1 square. So v1 is equals to root of 2g h1 I will get. If you understand these two here from motion in a straight line, then very easy to say what is the coefficient of restitution. From that, how to say the height. V1 is equals to, according to this formula, root of 2g h1 is equals to, I write substituting here, Nana. V1 is root of 2g h1 is equals to E into U. U, I write here root of 2g h. So here if I square on both sides, 2g into h1 equals to, I will get he square into 2gh. Okay, so here 2g cancel. In the first bounce you will get, this is e square into h. This is the formula what we get here. Okay, this is the height what he asked in the first bounce, and this is the velocity with which it bounces back in the first bounce. Okay, so these are the two answers, equation 1 and equation 2. Okay, here this equation I got from the equation 1. We get here, substituting v1 value and u value in this equation. Okay, so u and v1 both I substituted in the equation 1. Now, if you have any doubt here in this question, you can ask. Do you have any doubts related to this question? Velocity with which it rebounds? Okay, thank you. No, sure, all of you. Okay, today I'm getting very less response from the students. Right side part, Ishan, nothing I did here, Nana. Okay. I think you understood this equation. V1 is equals to U. How you got this one? You understood or not, Mr. Ishan? Okay, right. Then there to substitute in place of V1 and U, I require two equations in terms of height, Nana. That's why in terms of height, the velocities I'm going to check here. What are those velocities in terms of height? Observe, suppose not this question. If I ask in motion in a straight line chapter, if I ask you, Are Nana, one body is dropped from a height h, Nana, then with what velocity it strikes the ground? Then what do you say? The velocity with which it strikes the ground, sir, already you told in motion a straight line, that is root of 2g h, sir. Do you say or not? Yes. Okay. So right side what I took, the velocity with which it strikes the ground, he gave it as u in the problem. That's why it is u. U is equals to root of 2gh. Now you understood why I took u is equal to root of 2gh? Say simple, yes or no? Yes, okay, right, good. Next, after hitting the ground, suppose that is a ball, ball usually its behavior is, its nature is bounces back. So it bounces back here like this. Suppose with a velocity, with a certain velocity here, some velocity, say u is given. It raises to what maximum height? If I ask, what do you say the maximum height attained by a body when it is thrown vertically upwards with a velocity u? Maximum height formula is equals to, what do you say? U square by 2g or not? Good. U square by 2g. This height after bouncing, he gave it as h1 in the problem. Nana. So h max is h1 is equals to u square velocity with which it bounces back in the problem given as v1. So v1 square by 2g. That I took here. Now you understood the right hand side part? Yes or no? Yes, 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 yes. Good. I think rest of the part no need to explain. Just cross multiplication, taking square root, substituting these two in the first equation. Okay. I think you did have any doubt in that part. Okay, Nana? Right, good. Come to here. If you understood, yes, yes, okay, right, good. Mr. Ishan. Next here, if I ask in the same question, example 2, this is example 1, okay. Suppose I say, in the first bounce, it bounces back to a height h1, okay, which is less than h, that you can say. Why? Because e is less than 1. Since e is less than 1, we can conclude that here h1 is less than h. Here we can write, okay. So it is your responsibility. Why? Because you dropped the ball from this height. So even though it is not reaching to your hand level, you have to lower down your hand and you have to catch the ball here. Okay. But you are too lazy. That's why here you did not catch that ball. Then what happens? It won't wait there. After raising to a height h1, if you don't catch the ball, again it falls down. Again it falls down. Here again it falls down and strikes the ground with what velocity, Nana? Since it is raised, suppose with a velocity v1, in case of kinematics, that is motion in a straight line. Suppose if I ask, not related to this question, suppose if I throw a ball vertically upwards, it reaches to a maximum height and again it will fall down. While falling down here, with what velocity it strikes the ground? If I ask, what do you say? If it is projected with a velocity u, it strikes the ground with the same velocity or different velocity? Same. Where different? Is it different or same? It strikes the ground with the same velocity, Nana. What we discussed in the motion is straight line. The velocity with which the ground is equal to the velocity with which you project it up. Since it is in opposite direction, just we take minus. That's it. Okay. Yes, it is a ball thrown vertically upwards. Yes, yes, yes. So here, what I am asking, in this model, at the first bounce, it raises up with a velocity v1 in the first bounce. Or raises to a height h1 in the example 1. Yes. Now it is your inability, you did not catch the ball. Then what happens? Again, it will fall down. Okay. So to understand that part, I am drawing that one separately, that the line. Okay. Again, it will fall down from that height h1. Okay. And hits the ground here. And here, observe, it is falling down from what height now? It is falling down from what height? H1, exactly, Amaya. Thank God, Lakshmi Gayatri. This time you responded. H1, right, good. Okay, it is falling down from a height H1 and it strikes the ground with the same magnitude of velocity, what I explained just now, strikes with a velocity V1. Now it is the second bounce. Okay, after striking the ground, immediately it will bounce back. Okay, it will bounce back here, that I represent with another color, bounce back, suppose with a velocity v2 and raises to a height just h2 in the second bounce. Okay, personal doubts, personally only. So it raises to a height just h2 up to here. Then how can you interrelate v2 and v1? Striking velocity, rebounds velocity. How you interrelate the striking velocity and rebounds velocity at the second bounce, not at the first bounce. Okay. Okay. I am not asking this one, Nana Manikanta. I am asking what the relation, like this equation. V1 is equals to, finally you got EU na, in the same way. What kind of relation you will get here in between V1 and V2? There you give in the first bounce, V1 and U are interrelated like this now. The striking velocity, rebounds velocity, you interrelated like this. In the same way, the striking velocity and bouncing velocity, how you interrelate? I will see who will catch this simple common sense. 10, 9, 8, 7, 6, 5, 4. No, Manikanta. 3. These are not numbers. Counting down. 2, 1. Oh my goodness. Not Ishan. And 0.75. Oh, no. 0.5. 0.4. 0.3. 0.2. 0.1. Ayyo. Okay. 0.05. 0.04. Okay. Right. No one is getting. 0. Right. Thank you. Right. Simple, Nana. Here at the first bounce, what? No, Manikanta. Observe the common sense. Simple common sense. Strikes with a velocity u, bounces with a velocity v1. Then these two are interrelated at the first bounce as v1 is equals to eu. Am I right? Follow my common sense here. Strikes with u, bounces with v1. So v1 is equals to eu. Means bouncing velocity is equals to e times to striking velocity. Once again, I'm repeating. Bouncing velocity is equals to e times to striking velocity. Third time I'm repeating. The bouncing velocity is equals to e times to striking velocity, Lakshmi Gayatri. E times to striking velocity. Now you are right. Ammaya, oh my goodness. I need a glass of, not glass, bottle of water. Okay. Right. Second bounce you observe here, Nana. Yeah. Thank you. Right. Okay. I did not see, Nana. It's my mistake. Sorry, please. I can't say how sorry I am. Here, observe the striking velocity second bounce instead of u, that is v1 at the second bounce. And bouncing velocity here, instead of v1, I have here v2 at the second bounce. So using the same common sense, bouncing velocity, here bouncing velocity is v2. So v2 is equals to, bouncing velocity is equals to e times u, striking velocity. Striking velocity at the second bounce is v1. E into v1. Now you understood this step, Nana? All of you? Yes. So at every bounce, Nana, not only at first bounce, yeah, good. And not only at the second bounce, not only at third bounce, but also at the nth bounce, you can take the same formula. Bouncing velocity is e times to striking velocity all the times. Okay. Suppose if I ask at the third bounce, you say the formula. If you understand the concept at the third bounce, bounces back with a velocity v3 is equals to. Excellent, Lakshmi Gayatri. Others, v3 is equals to. Yeah, very good, Tanisha. Nice, good. Charmi Priya. V3 is equal to u3. V3 is equals to e times to v2. E times to v2. Right, correct. At the fourth bounce, v4 equals to. Yeah, good. Now you are following. Yeah, nice. Yeah, thank God. All of you following here. No problem. So at the second bounce, yeah, good. V2 is equals to EV1 you wrote. That what I said. Okay. Here in the example 1, find the velocity and height reached at the second bounce. At the second bounce. This is the question. Okay, right. Now here come to the formula here. Solution. As we know, the bouncing velocity is equals to E times to the striking velocity. We write V2 is equals to EV1. You can stop here, no problem. This is correct. But already you know V1 is equals to how much now? So why should you stop here? That implies again, since V1 is equals to EU, from the example one, V1 is equals to EU. Right. Why don't you write V2 can be written as why don't you write V2 is equals to E into V1 is EU. That implies V2 is equals to E square into U, nano. Yeah, is it correct? E square into U by multiplying this one? Yes, yes, yes. Sir, why you said in terms of U, sir? Why don't you stop the equation here? Why? Because in the numericals, they give the velocity with which it strikes the ground at the first bounce only they give. Then they will ask, find the velocity at the second bounce, at the third bounce, at the fourth bounce, at the nth bounce. So I am going in the same way, again, use the common sense. What common sense, sir? Look at here. At the first bounce, I got e power 1. Observe, at the second bounce, I got e power 2. I think you caught my logic. E power 2n. Array, Lakshmi Gayatri, what you observed? At the third bounce, now it is correct, like Akhil. At the third bounce, e power 3 into n. At the nth bounce, e power n, right? E power n into u, correct. This one I am going to write here as a shortcut formula. Okay, right. Note here I am noting that point. When a body or ball is dropped from a height h and strikes, not thrown, dropped, keep in mind. Okay, it is dropped means initial velocity while dropping here is equals to 0. Not thrown, just dropped. So from a height h, better I underline that dropped word here. What happened? Dropped, I underline, not thrown. So here from a height h and strikes the ground with a velocity, then at the nth bounce, the rebounding velocity, bouncing velocity is Vn is equals to what you told, e power n into u is the shortcut. Okay, so keep in mind, remember this formula for numericals. At the fourth bounce, directly you put e power 4 into u. at the 10th bounce, e power 10 into u. It will be very easy to you. Okay. And the next point here is use the same common sense, Nana. Okay. Sir, at the first bounce, the striking velocity is okay. That even if I explain, it will be very hard to understand. Observe the common sense here. H1 at the first bounce, it rebounds to a height. You got e power 2 into h. Follow the logic. Means h1 you got here e power 2 into h is e power 2 into 1 into h. Now I see how many caught my shortcut here. Yeah, at the second bounce I am asking exactly. Yes, very good, Ishan, very good. H2 is E square. Yeah, exactly. What you said is correct, Lakshmi Gayatri. Even that is also correct. That is Ishan told, that is also correct. H1 is again E square H. That is E power 4 into H. That is E power 2 into 2 into H. Correct enough? Is it correct enough at the second bounce? Yes. At the third bounce, in the same way, E square into H2, of course, you can say. Finally, what do you say? E power 2 into 3. Yes, good. E power 2 into 3, that is 6h. Yes. Yes, I'm going to that point only, Akhil. At the nth bounce, what I supposed to write here? E power n or e power 2n? Ishan? Ishan. Right, good. Yeah. E power 2n into h. Right, good. This is the shortcut what I'm going to write here, the second point under the note. Okay, I think all of you understood. Shall I erase this part, Nana? Okay, directly I write this shortcut there. Yes, okay, good. So after erasing this part, directly I'm coming to this shortcut there. Yes, the note point 2 here. Okay, what I'm going to write, the height raised in the nth bounce. Yeah, that's what I'm saying. You can use this shortcut. At the nth bounce, is hn is equals to e power 2n into h. You can use the two shortcuts. Okay, one for the velocity, other for the height. Okay, now use this shortcut and solve my problem, Nana. Here, suppose this is one problem. Okay, problem 1. Okay, not MI10 Pro. This is problem number 1. So here in this problem, again I am saying same words here. A ball is dropped from a height h. Again dropped only, not thrown. Dropped from a height h. Okay, and bounces repeatedly. Why? Because we did not catch that ball. Bounces repeatedly. Repeatedly, number of times, many number of times. Almost you can extend that number up to infinity. That's why I told many number of times. Means infinite number of times. Okay. Find the total distance and displacement covered. Okay. This is the question. Means here you have to extend this number. Displacement, I think it is not 0, Lakshmi Gayatri. Okay. Here first I go to distance, Nana. Observe. Yeah, not 0. Correct. Observe here. Suppose when a body is dropped from a height h, Nana. Now the first bounce starts. No, 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 no. First bounce starts means at the first bounce, better I draw separately, Nana, to understand. At the first bounce, it suppose raises to a height h1, raises up and again falls down, raises h1, again falls from a height h1. In this case, shall I say distance is 2h1 and displacement is 0 after the first bounce, Nana? Is it correct? Yes. Displacement is 0 for this pink color part. Displacement is 0. Distance is 2h1. This is at the first bounce, Nana. Okay. If I ask the total displacement, I have to write h plus 0 na, after completing the first bounce. So Lakshmi Gayatri, observe here. I think it is not 0. Okay. In the same way, observe the second bounce. I move to the other color. Here, second bounce, you observe. Again, it raises to some height h2 from here. Okay. This is raised up h2 and again fall down h2. So here displacement is 0, but distance is 2h2 at the second bounce. All of you following my logic? Yes, yes. How h and Nana? Here it is dropped from this height. So already covered a height h before striking the floor. So h at the first bounce plus h1 and displacement, if you want to write, plus minus h1. Now you understood who is this? Lakshmi Gayatri? Yes, yes. So I think there is no question of how h. Am I right? Right, right. Good. So here at the after the second bounce also, if I ask what is the total displacement before striking the floor h, and raises and down, this is 0 displacement and this is also 0. So what the common sense you are following here, even after n number of strikings, you will get plus 0, plus 0, plus 0, plus 0, so on, so that total displacement equals to h. Is it correct? Right. So displacement part is very easy, Nana. Yes. So after n bounces, displacement is equals to, straight away I'm writing here, displacement, okay, is equal to h plus 0 plus 0 plus 0, so on. That implies displacement s bar, I write, that equals to h. So do you have any doubt in this concept, Nana? Like h plus 0 plus 0 plus 0 plus 0 plus so on. Do you have any doubt? No. Very good. Thank you. Now move to distance. Okay. Second one is, he asked what distance. Distance is equals to, observe there, Nana, h plus, I should not write 0 at the first bounce. I have to write 2h1. Is it correct? Right. Good, 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 good. That only I'm going to get, Nana, right? At the second bounce, I should not write 0, 2H2. At the third bounce, I should not write 0, 2H3, plus so on I will get. Okay. So I write total distance S is equals to H plus 2 H1. That shortcut I'm going to e power 2n into H shortcut I'm going to use here. Yeah, n is 1 first bounce. So e power 2 into 1 is 2. 2 e square h I write plus 2. H2 means e power 2 into 2, 4. E power 4h. Sorry, h I will write down. Plus 2 into, I think you understood, no need to explain. E power 2 into 3, 6h plus so on. Okay. Do you have any doubt here, Nana, regarding this point? Distance. Okay. Now I will extend one more step and I will leave it to you only to solve. Okay. Just h plus. Here I am not taking h common. Why? Because if I come after the first part, I can take many things common. In all these parts, I can take 2 common, h also common, and in all e square also common. That is the advantage. So 2 e square h, if I take common, I will write from here 1 plus here e square plus here 2 is there, 6 is there. 2 plus 4, 6. So e power 4. Oh, I understood. E power 0, e power 2, e power 4 means next one will be e power 6 plus so on I will get. Is this step correct, Nana? The distance S is equals to? Yes, this one you solve and say the answer for in the next class. Okay, I'm going to stop it now, Nana. If you want the pages, you can take. Even if you have any doubt, you can raise. Shall I move to first page? That one you have to solve now. This is actually geometric progression, Lakshmi Gayatri. Geometric progression, infinite series, what is the sum? If you know the formula, then you can substitute here. The geometric progression, GP. Right, come to here, first page. Second page. And third page. Yeah, do the geometric progression. Take the sum of infinite series. Okay. After taking the sum of that infinite series, substitute and solve this one. Say the answer in the next class. Okay. Bye everyone, and have nice Sunday. Thank you. Thank you. Bye everyone.